All right, let's get right into it. What people? All right, sound intensity. We've also, have we dealt with this formula? We have. Remember the orders of magnitude stuff where we just subtracted? Now we're not going to do that. We're actually going to do it the real life, like how do we solve these using logs? I'm going to give you actual tools to solve these real life equations using logarithms, okay? So we are looking at, sound intensity. So I have an equation, right? What do they tell me some stuff? Loudness is 10 times log of L over L initial. L is the intensity of sound. Or is that I? Should be I. Yeah, it's intensity. And that's the low that can detect. So for this one, what's our Bob number going to be on that beast? 10 to the negative 12. What am I looking for on this? What's given to me? What's the decibel level of a normal conversation with intensity of 10 to the negative 6? Does that go for big L or for I? What am I looking for? I'm looking for a big L, which I've been taking my whole career. I'm looking for decibel level. So that's capital L. So now let's just plug in. I do 10 times log. And what's my intensity? What's my I? 10 to the negative 6. Not capital I. That'd be, yeah, it's capital I. So I'm going to put in 10 to the negative 6. And then what's my initial I? What's my I sum? Oh, not initial, but 10 to the negative 12. All right. So far, so good. Now, at this point, could I just plug it in my calculator? Yeah, but that's really lame. What if I told you I looked up 65% of the test is non-calculator on the AP Pre-Calc? So let's make sure that we can do this without a calculator as well, and I'm going to show you how. Yeah, that's a little more than half, as some students said. You guys are ready. All right. What do I do with these if they're both negative? What can I do with them? Flip them. So I get 10 to the 12th over 10 to the 6th. What do I do with my powers with the same base? Subtract them. Oh, no. So that becomes 10 to the 6th, right? What's my base on this? Wait a second. Log base 10 of 10 to the 6th? If they're the same, what do? They cancel. So L is 10 times 6. And 10 times 6 is 60 what? Hot dogs? What's L measured in? Yeah, decibels. So if my base is, so with sound intensity, since this is usually given in 10 to a power, can I do these without a calculator most of the time? You can. So be ready. These a lot of times are going to be non-calculator from what I've been seeing. We have to use our exponent rules. Don't you wish you could go back now and look at like Algebra 2 stuff with exponent rules? And it'd be like comical how easy you would find it at this point. You know what I mean? How often you've done it. Hopefully it's comical. All right, let's do this one. Uh-oh, backwards. All right, anything above 120 decibels will cause ear pain. A jet engine has 150 decibels. How many times more intense? How many times more intense is it than 120? How are we going to do this? What do I have to? I have to find, if I'm finding a ratio, I have to find both lowercase or both i's, right? So I have to solve it twice, right? So I have to set up 120 equals 10 a log of what over what? Of what I'm looking for over, what was it, 10 to the negative 12? So I have to solve for I on that one. Now, can I do this one with a calculator relatively? Yeah, let's do it that way. I'm not going to do it that way. They did a system of equations. I don't know if I agree. So let's do it. So this is 120 equals 10 times log. Can I do this? Log of I minus, oh, I wouldn't do it that way, but whatever. Minus log of 10 to the negative 12. Can I do that? Because it's division, right? Y'all agree or disagree? All right, so now what is log? These cancel, correct? It's a negative 12, which makes it a positive 12. And this is going to be still log base I, right? Can I get rid of that 10? I'm going to divide by 10. One of the biggest fallacies I think that is taught in algebra is to distribute when solving a problem. A lot of times, if you have a number in front, isn't it easier just to divide it and then you don't distribute it? I hate that that's hit so hard in algebra. Because it's a lot easier just to do, well, then 12 equals a log of I plus 12. So what's log of I equal to? Like the amount of money in my bank account. So 10 to the 0 equals I, which is 1, right? The intent, oh, dude, I wrote that way too big. We have to do this all again. Uh-oh. Ruh-roh, SpaghettiOs. Nice job. That was well done. Nice job. Nice job. I like the sweatshirt. Let's go. You know, extra credit. Minus 1,000 points. Packers stink. Nah, I'm not telling that to you. I'm telling it to the people out there. Jordan Love loves to throw picks. All right. I don't care. I know. Hey, at least they're better than Cowboys. Cowboys are the worst. We can all agree on that. Boo, Cowboys. More like the Cowdoys. All right. All right. We have to do it all again. But can I? I'm going to show you something. Can I skip a whole bunch of steps? I'm going to jump right ahead to this equation right here. I don't know why I did this. Why can I jump right here? It's going to be the same equation, right? If you guys don't see why I did, I can go through and do it. I actually could even skip further ahead and said it's log of I minus or plus 12, right? I could have done that because I know they're the exact same equation. I'm going to do the exact same steps. And I'm lazy. I could have jumped. Actually, I could have jumped really. I could have done 15 equals log. I digress. All right. If I was doing this for real, I would have actually jumped to this step right here. I would have jumped there. Because the right side is exactly the same for both equations. The only thing that changed was the 150. All right, divide by 10. I get 15 equals log of I plus 12. So what? 3 equals log of I. So 10 to the third equals I. Ooh, you guys want to do something wild? I'm going to call this I of J. Because it's a jet engine. So how many times greater is a jet engine noise than painful? So I do I of j over I of pain, I of p. What is 10 to the third divided by 10 to the 0? It's 1,000 times greater. So think about that. Between 120 and 150 decibels, you're like, that's not that big of a difference, right? It's 1,000 times more. It might hurt a little bit.
Like different volume levels on your AirPods.
Did you know actually sound is really interesting because all sound is damaging to your hearing. All sound is damaging. But low decibel takes a long time to be painful. The higher the volume, the more damage it does quicker. Like one big boom can permanently damage your hearing, right? Like in the film, what was I going to say? Like in the film Baby Driver, how's that for an old reference?
I know that.
The guy takes out his hearing. That's it. I really like that movie as well. I highly recommend. I recommend Baby Driver. Don't recommend Packers or Dallas Cowboys. Don't let your friends become fans of those teams. They need to feel misery like Lions fans have over the last forever. It's going to make it so much sweeter when they, I hope. They're going to make him eat turf. All right, here we go. Carbon dating. Carbon dating, I hardly know him. All right. Okay. So half-life formula, do we know it? It's actually, half-life is one of the ones that is not bad. It's always like y equals your initial. What's our rate of change for half-life? What are we looking for? Half. So our base is always a half. And now it doubles in 5,730 years, right? Or halves in 5,730. So that goes on the bottom because then when I plug in 5,730, I want that to be a 1, right? I want it to be to the first power. So if I put x over that, when it reaches that, I'll be at half of what I started. I don't know. If you do a lot of math and bio, you do a ton of half-life and you just get used to seeing it. If you recall, they taught this a different way a long time ago, and I kept using this way, and the formulas didn't match up. They used it as an E, which is actually slightly more accurate, but this is pretty good. It's close enough. I don't want to do like natural log over to like figure it out. All right. So we dig up a bone, and we find that 60% of the carbon-14 is gone. I want to know what? I want to know how long has it been there. So 60% is gone, right? So I'm at 60%. I'm at 0.6 of my initial. 60% of 100, so my A is 1. Right? I start with 100%. I'm ending at 60%. I don't worry about A. So I set my formula, right? Okay. Oh, mamma mia. Exponents. How did I get rid of exponents? Log. Natural log or log to the base 10? Doesn't matter? No, because do I have a, well, could I use log of a half? I could. Why didn't they do it that way? They do, actually.
I feel like you need so much space.
No, I'm just going to do, you know what? I'm going to show you that way. I'm going to actually use natural log. And the reason why I'm going to do it this way is because it's the most common way to do it in calculus is you just always use natural log. So is natural log of 0.6 a number? Good. What do I do with my exponent when I log something? You move it to the front. And then this is going to be natural log of 1/2. Is that a number?
Yes.
Now this is a solvable thing, right?
Right.
How do I get rid of this? This would be a calculator. No, you got to use your tables from your slide rule. How do I get rid of this 5730? Yeah, you multiply it. I've used purple this whole time. Feeling very purpley today. So that cancels. How do I get rid of the natural log of 1/2? You divide by it, right? Could I just multiply by the reciprocal? Same process. Do you guys see what I did there? Multiply to get rid of that, divide to get rid of that. Because it's multiplying. They're numbers. There's no variables in that. Now, if this was a non-calculator question, this is a great answer, right? But this was, let's say it was a calculator. And you plug this in, and you are really careful when you plug it in. I got X is approximately 4,000.8. Ooh, hot dogs? Years. It's approximately 4,222.8 years. Now, is carbon dating hyper accurate? No, it's an estimate. So they said it was that, right? Can we disprove them with that number? No. It actually would say, oh, they're probably pretty close. Because what they do is they date stuff in the ground by where it's placed by other stuff, and then they use carbon dating to confirm or to. So I would say this doesn't disprove it, but carbon dating is an estimated age. So cannot disprove. Now, if I did this and got like 10,000, would you say that disproves that? Yeah, because that's really far away, right? That's relatively close, so we can't really confirm or deny. We say that's probably pretty close. But if we get a really wild number, they are not right. They're dummy. With carbon dating, get really into physics and chemistry, and the more you learn about like carbon dating, the more you realize it is a really good estimate. You know what they use now for really old stuff is actually uranium dating, because that can go back millions. It does. Its half-life is like